In this video, I'm going to do a full example solve of the 4x4 using a beginner's version of the reduction method. So in this video, I'm going to run you through an entire example solve for the 4x4. So let's start again with the white center. And notice that we've already got these two paired up here. So these two white center pieces are already in a line, and the remaining two are over here. So we can actually pair these two up by doing an R prime, a wide R prime like that, to move this centerpiece from here to here and match it up with this one. So doing that wide R prime didn't actually move this one at all, it only moved this one from here to here. So now we've got this line at the top and this white line at the bottom. What we can do is simply move this one across like that and then do a wide R2 to move it from the top, these two positions here, to the bottom down here. The next thing to do is to actually make a yellow line and insert it into the top. So we can use our wide turn to actually do that. So for example, here we have this yellow centerpiece and this one here as well. So when we do a wide U prime, this moves this one over to this position and pairs these two up. So now we can insert this line into the top. Remember, we can't just do a wide R like that because that breaks up these two centers. So we can do a wide R. Then we need to move these two across like that and then do a wide R prime to preserve this white center. So now we've got this line in the top here. Now what you need to do is match up this centerpiece with this centerpiece to create a line. And there are a few ways that we can do this. At the moment, if we're doing a wide U move, for example, like that, that's just moving these two around the U layer. So we need to move one of these two into the third layer from the top here and then pair them up. So we can move this one down to this position by doing an F prime using our outer layer, which only affects the centerpieces on this face. So we've rotated that. Now when we do a wide U, it pairs those two up and we can actually insert this line into the top layer here. So doing a wide L prime, U2, L. So what we did there was we replaced these two by doing we replaced these two with these two by doing a wide L prime, moved these two over here by rotating this top face, the outer layer, and then replaced these two and replaced these two so that these white and yellow centers are now solved opposite one another. After that, we can hold them on the left and the right and decide which center that we're going to solve next. So the first thing we saw were these two lines here, the blue center and the green centers. But we also noticed that when we did an X prime, so rotated this way, keeping the white on the left and the yellow on the right, we actually have this red bar here as well as this red bar on the front. So this is actually a really easy case. So we can just simply move this one over to the side here, move this one over to this side, so that when we do a wide move, we actually solve this entire red face. So that only took 3 moves to solve these 3 red centers. So now the slightly tricky part arises, which is where we need to decide which color needs to go here. So obviously it's not going to be orange because orange belongs in the back here, opposite the red stickers. So we're either going to need to solve the blue center here or the green center stickers here. Now if we remember our clockwise color order, which goes blue, yellow, red, like this, clockwise, that means that if we've solved the yellow and the red centers, then the blue center belongs here. So we've got this blue piece already. We need to find the remaining blue pieces and solve them into this face. So the remaining blue pieces are over here. So we need to somehow move all of these ones over to this face. The first thing we can do is move this one up to here. So doing a wide R2 actually moves these two up here. So connects this one centerpiece with this one up here. But it also messes up this red center and moves these ones to the back here. So we need to replace this red one. So we can do this by moving this out of the way by doing a U prime. So moving these blue ones out of the way. Then when we bring the red ones back by doing a wide R2, these two stay in position where they belong. So after solving these two, we need to solve the remaining 2 blue pieces into this position. And the remaining 2 blue pieces are over here. So we can do something like this. So if we do an R2, that brings these 2 red ones over here. So this red center is off by an R2. And if we do a U2 to move these 2 blue ones from these 2 positions into these 2 positions, then when we do an R2 back, it solves both this blue center and the red center here. So if we have the blue center on the bottom, that means we need the green center on the top, and by default the orange center belongs on the front. Here we have a nice case where we already have two lines. So we have this green line and this green line here. So all we need to do to solve them is, again, replace it, do a U2, and then slice back. And now we've solved all of our centers. So after solving all of our centers, it's time to solve the edges. Again, we're going to solve the white edges first, just for simplicity. Firstly, the first one I see is this white and orange edge, and it's white and orange partner down here. And what we can do to actually move this edge from the bottom up to here is simply do an R. And you'll notice that as you practice, you'll get better at actually moving the outer layers to position two edges across from one another. But basically, yeah, that'll come with practice and getting more familiar with the 4x4 cube itself. But basically, because this white sticker was facing the bottom and because this orange sticker was here, if we did an R, that would put this into the front right slot and the white sticker would be facing the front. After that, we can do a slice move to pair them up, insert an edge that's not solved, and then slice back. And now we need to look for another edge pair. As we were slicing back, I actually noticed this white and green edge, and its corresponding white and green edge partner is up here. So we can move this green sticker down to this position where it belongs. So remember, in the same face on the front, on the left and the right, but they need to be in different layers. So this one's in the second layer, this one's in the third layer, and they have different stickers as well. So that's how we kind of align them to get them ready to actually slice and pair them up. So this one's up here in the top position in the front left slot. This one's down here in the bottom position in the front right slot. So when we do a U prime to actually bring this one from there to there and pair them up, they get paired up. And now what we can do is actually just insert one of these unsolved edges into this slot and then slice back. Okay, let's solve another one. I actually see that we've got these two already positioned. So we can do a U prime, a U like that to solve this white and blue pair. Insert an edge from the top, and then slice back. So that one was pretty straightforward. Now we've got these two, the white and red and the white and red up here. So we can do something like this. So U prime, R prime to move this white sticker here. So now that when we do a U prime like that, a wide U prime, they get paired up, and we can insert another unsolved edge and slice back. So now we've solved the 4 white edge pairs. It's onto the yellow ones. So let's look around. There's a few that we can choose from. The one I would like to do is probably this orange and yellow one and this orange and yellow one over here. To insert this yellow sticker to this position, because we have the orange sticker of this edge piece down here, we can do a U2 R prime like that. So now we can just do a wide U to pair these up, insert an unsolved edge, and then slice back. Next up, we need to find another yellow edge pair. Just for simplicity, we're going to keep going with yellow. So we've got this one and we've got this one. Now to move this blue and yellow edge down to this position, we need to do something slightly different. So normally to insert something like this, the easy way to do it is do R, U prime, R prime, like that. But that actually inserts this edge down here, which is not what we want, because when we slice, we're actually not going to be pairing these two pieces up because they're in the same layer. They're in the same slicing layer. So undoing that, there's a different way we can move this blue sticker over to here, which is where we need it in order to pair up these two edge pieces. So this one and this one, so the yellow and blue ones. So we can do something like this. So F, R prime, F prime, R, like that. So that moves the yellow edge that was here to this position. Now we can do a simple U, a wide U to pair these two up, and then insert an edge that's unsolved from the top layer into the middle layer, and then slice back. Now we need to do the same sort of thing with the last pair of yellow edges. However, this time we have this yellow edge down here in the front right position, and we need to move this yellow one to this position with the green sticker on that sticker exactly. So we can do F prime, L, F, L prime, like that, to move this sticker, this piece from this position to this position. Then when we slice by doing a U prime, by moving this edge on top of this edge, we can insert this unsolved edge into the front right and then slice back. So now we've solved all of the 4 yellow edge pairs, and actually we got a little bit lucky because the blue and orange pair was connected and the green and red pair was connected whilst we were solving those first 8 edges. So we only actually have 2 edge pairs left to connect to one another. Here we're already set up to the flipping case. So here's the algorithm where we have these two that need to be paired up. So these 2 edges, the blue and the red and the blue and the red, and the green and the orange and the green and the orange. So we only have 2 edge pairs left to solve, and we do it using the flipping algorithm. So we slice first by doing a U prime, a wide U prime, flip by doing R, U, R prime, F, R prime, F prime, R, so that when we slice back, this edge will match up with this one, and this edge will match up with this one. So slice back. And now we've reduced it to a 3x3. So we go ahead and do the 3x3 stage. So the first thing to do is your cross. It's probably okay to solve the cross on the top layer because you don't really get inspection time and you probably want to see what you're doing as you're solving the 3x3 stage. So we can just kind of solve, it's probably easy to solve one at a time into the top layer. So for example, this white and red edge pair, this white and green one, this white and orange one, and we can misorient this, well, we can reorient this white and blue one by doing a D before we did that last R, and then insert that one up to the top there. So it's okay to do the cross on the top because it's a little bit harder because you don't have inspection time to actually plan out your cross after you finish your reduction part of solving the 4x4. So then what you'll do is you'll flip it over and go ahead and solve the first 2 layers. In this solve, we didn't get OLL parity, but if you do, the algorithm that you should do is the OLL parity algorithm. Here we don't have it because we only have 2 edges oriented and 2 edges misoriented, so both even numbers. However, in this solve, we do actually have PLL parity because if we solve our corners, so let's solve our corners first, and if you do 2-look PLL, 2-step PLL, you should always solve your corners first before actually doing PLL parity algorithm. That makes it just a little bit easier. So go ahead and solve our corners. So now we've solved our corners, we actually have a position which isn't possible on a 3x3 cube. So here we have 4 edge pieces or 4 edge pairs that are unsolved, but we don't have either the H permutation, which involves 2 opposite swaps of edges, nor do we have the Z permutation, which involves 2 adjacent swaps of edges. So we have a combination of both. So we have this edge which needs to go here, this one needs to go here, this one needs to go here, this one needs to go here. So a combination such as this isn't possible on a 3x3. So for example, if we were to just do a U permutation, which solves this edge over to here, this edge over to here, and this edge over to here, so an anti-clockwise U permutation, we can actually see that we have a case where we have 2 edges swapped, which is a case that we can't get the equivalent of on a 3x3. And so what we need to do is do our PLL parity algorithm. Here we're perfectly set up because our PLL parity algorithm actually just swaps this front edge pair with the back edge pair. So we do a PLL parity by doing small r2, u2, small r2, wide u2, small r2, wide u2, and then a u2 to finish. So yeah, you'll have to do that PLL parity algorithm if you have parity, and you can either do it before you permute your edges or after you've permuted a few edges. So I hope this example solve was more useful to help you solve the 4x4 cube more confidently.